In RT2-2, you will learn to simplify, add, subtract, multiply, and divide radicals. It'll be really important today to remember how to factor. So I want you to think about some strategies that you know that might help you find factors. So when you were learning about finding factors, you learned factor trees. Maybe you learned how to factor using one of the cake method. Here, let's recall. Let's do an example. If we were going to factor 60. So if I'm looking to figure out the factors of 60, I want to first consider what can I divide 60 by. One thing I could would be 6 and 10. 6 times 10 gets us to 60. I can get to 6 by multiplying 2 times 3, and 10 is 2 times 5. This is far down as I can go because these are all prime numbers, which means that 60 really is 2 times 3 times 2 times 5. This is going to help us today with simplifying factors, and that's because I'm going to look at pairs of factors. So here we have 2 and 2. Those are pairs of factors. This tells me that 60 is divisible by 2 squared, which is going to help us with our radicals. So this is going to be really helpful for us when we're simplifying radicals. The first thing we need to do is find the largest perfect square that is a factor. So for example, if we're looking at the square root of 48, I know that I can divide 48 by 4. 4 times 12 gets me to 48. And I can now break this up into 2 radicals. Square root of 4 times the square root of 12. I know the square root of 4 is 2, so we have 2 square roots of 12. Then I need to look at what's under my radicand and see if that can be simplified at all. If I can find other square roots, perfect squares that I can take out. 12, I could rewrite as 4 times 3. And again, I'm going to take out the square root of 4 and write it as square root of 4, square root of 3. Then I know that the square root of 4 is 2. So I'm going to multiply 2 by 2, square roots of 3. 2 times 2 is 4, 4 square roots of 3. 3 I cannot simplify any further, so this will end up being my final answer. If I go back up, I could have maybe seen that I can take 16 and multiply it by 3, and that gets me to 48. 16 is a much larger perfect square. It's actually the largest perfect square that goes into 48. So it would actually make my process a little bit quicker. And I'd change it to the square root of 16 times the square root of 3. Square root of 16 is 4, square root of 3. So I would still get the same answer. It's just a matter of how long it would take me to get to the same answer. And you can again see those steps written out. So step 1, find the largest perfect square. That is a factor. 2, rewrite under the same radical. 3, rewrite under separate radicals. 4, simplify perfect squares, and then check. You want to make sure that your final answer is as simplified as it goes. Let's take a look at some examples. Let's start with the square root of 28. Again, I'm trying to think of a number that is a perfect square that goes into that 28, or that's divisible by it. So a factor here is 4. We know that 4 times 7 gets me to 28. I'm going to rewrite it as the square root of 4 times the square root of 7. The square root of 4 is 2. We have 2 square roots of 7. I can't simplify square root of 7 any further, so that's our final answer. Now let's take a look at the square root of 75. Again, I'm thinking about perfect squares. I know 75 is divisible by 25, and that's 25 times 3. I'm then going to break it up into the square root of 25 times the square root of 3. The square root of 25 is 5, so I have 5 square roots of 3. I cannot simplify the square root of 3 any further, so that's my final answer. Let's look at the negative square roots of 63. Notice the negative is outside, so we just keep that negative on the outside. I know that 63 is divisible by 9. 9 is a perfect square, so that's great. 9 times 7. I'm going to rewrite it as the square root of 9 times the square root of 7. Square root of 9 is 3, so negative 3 square roots of 7. I cannot simplify square root of 7 any further, so we have our final answer. Okay, let's look at the square root of 80 there. As I look at the square root of 80, again, I'm thinking about those perfect squares I can divide by, and I know that I could divide 80 by 4. And that would be completely fine if you wanted to start with 4. However, there is a greater perfect square, and that is 16. I know that I can break 80 up into 16 times 5. And again, if you wanted to use 4, that is totally fine. You just have a few more steps. I'm going to use 16. So So I have the square root of 16 times the square root of 5. The square root of 16 is 4, so I have 4 square roots of 5. If you had done 4, it would have been the square root of 4 times 20. Then you'd have square root of 4 times square root of 20. Square root of 4 is 2, square root of 20. You would at this point have to keep going because 20 is not simplified, so you'd keep simplifying there. Let's now look at the square root of 96. Pause the video to give it a try and then press play to check your answer. You should have gotten 4 square roots of 6. I show here the 2 different ways you could have done it. Had you only seen that you could have divided 96 by 4, you could have gone the route on the left, or if you realize that you can divide 96 by 16, 16 is the largest perfect square, so it gives you fewer steps. Either way is totally fine. All right, we can also simplify radicals that have variables underneath them as well. And as we look at 98x cubed x squared, we are going to think about x cubed as being the same thing as x squared times x, because when we have a square root, okay, and an x squared, those actually cancel and that just becomes x. So then we'll be left with x on the outside and still an x underneath our radicand. So we're going to use that strategy here. But first, we're going to simplify our number the same way that we have. And we want to consider, okay, 98, what can we divide 98 by? If I think through the perfect squares, I divide by 4. It's not an integer, so 4 is not going to work. 16 doesn't work either. 25 for sure doesn't work. I can keep going. 98 divided by 36, that doesn't work. Next one would be 49. So 98 divided by 49, yep, that works great. So I'm going to rewrite this as the square root of 49 times 2 times, remember we're going to break x cubed up into x squared and x, and then I have times y squared. All right, now when I break this up, I'm going to rewrite it as the square root of 49 times the square root of x squared times the square root of y squared. I'm taking all the ones that are going to end up canceling with the radicand, and then that's all going to be multiplied by what's still going to be left, which would be the square root of 2x. So here we have the square root of 49, which is 7. The square root of x squared becomes x. The square root of y squared becomes y. And then I still have the square root of 2x. Let's take a look at 3 square roots of 343xy squared. 343 I know is divisible by 49, so we're going to rewrite that as 3 times 49 times 7 times x times y squared. So now I have 3, I have square root of 49, and I'm going to bring my square root of y squared to the left, and then I'm going to end up being left with square root of 7x because those will not reduce any further. So I have 3 times square root of 49 is 7, times the square root of y squared is just y, times 7x. So we have 3 times 7, which is 21. We need to make sure we multiply those two numbers on the outside. 21, y, square root of 7x. This is as simplified as we can go. Let's take a look at this last example here. As I look at 196, I could consider that I could divide it by 4. And it would be 4 times the square root of 49, which I could also then realize that are both perfect squares, and 196 is actually a perfect square. So we can break this up into 6 times the square root of 196 times, remember with x cubed, we want to rewrite it as x squared times x, and then times our y squared. So here we have the square root of 196, square root of x squared. I'm going to bring that y squared in front, and then we'll end with the square root of x staying under our radical. The square root of 196 is 14, so we have 6 times 14. Square root of x squared is just x, square root of y squared is just y, and then square root of x. We do need to do 6 times 14, which is 84. So we have 84x, y, and then square root of x. Just a reminder, make sure that you are careful if there's a number on the outside that you're bringing it down as you go so you do not forget about it. Let's look at adding and subtracting radicals. The first thing we need to check for is, are the radicands the same? So if we look at our example, we can see that we have the square root of 3 and we have the square root of 75. Those are not the same. So the second thing we're going to ask ourselves is, can we simplify either of them? And we can. We can simplify the square root of 75. So let's go ahead and simplify the square root of 75. We know we can do 25 times 3, square root of 25 times square root of 3. We have 5 square root of 3. So we're going to bring that over here, and we have 2 times 5 square root of 3, and I bring everything else down. I'm going to do 2 times 5 to get 10 square root of 3, and we still bring everything else down. Step 4. Now, are the radicands the same? They indeed are. We can consider these being like terms. So now all we're going to do is we're going to add the numbers on the outside. So I'm going to go 5 plus 10 is 15, and we keep the same radicand. So square root of 3. 15 square roots of 3 is our answer. This will be the same process for subtracting. Now let's go ahead and practice. All right, let's take a look at our first example. And I can see that they all have the same radicand. So what I'm going to do is I'm going to add them all together. I have 1 square root of 3 plus 2 square root of 3 plus 5. So 1 plus 2 is 3 plus 5 is 8. So I get 8 square roots of 3. Looking at our second one, I can see I have the square root of 7 and 5 square roots of 7. The one in the middle with the square root of 6, that cannot be simplified, but it doesn't have the same radicand, so it is just going to go along for the journey. We have 5 square roots of 6, and then I want to do 1 square root of 7 minus 5 square roots of 7, which is -4, or minus 4 square roots of 7. And we are going to leave our final answer like that because I can't simplify square root of 6 or square root of 7 to make them have the same number under the radical symbol. Looking at our next example, we have the square root of 3 and the square root of 27. Those aren't the same radicand. I know I cannot simplify the square root of 3, but let's try to simplify the 6 square roots of 27. I know that I can simplify 27. It could be the square root of 9 times 3. So then I have 6 times square root of 9, square roots of 3. Square root of 9 is 3, so I have 6 times 3, square roots of 3. 6 times 3 is 18, square roots of 3. And now I can see that I have square root of 3 for both of my radicands. So I am simply going to add 5 and 18 together to get 23 square roots of 3. Go ahead and try that first example on this slide. Press pause and then play to check your answer. You should have gotten 6 square roots of 2. You needed to simplify the square root of 8. Let's go ahead and look at the next one. On this next one, I have the square root of 45 and I have the square root of 20. As I look at this, I realize I'm going to need to try to simplify them both. So let's start with the square root of 45. I know that I can break 45 up into 9 times 5. I want to make sure I bring that -3 down. So we have -3 square roots of 9, square roots of 5. Square root of 9 is 3, so -3 times 3, square root of 5. -3 times 3 is -9, square roots of 5. Now let's try to simplify our 20. So we're going to have the square root of 4 times 5. We've got to make sure we bring down that -2 so we don't forget it later. We're going to break it down into square root of 4, square root of 5. Square root of 4 is 2, so -2 times 2 square roots of 5. -2 times 2 is -4 square roots of 5. So here now we have -9 minus 4. We get -13 square roots of 5. Looking at our last problem, I see, oh, hooray! It's 18 under both radical symbols, so I can go ahead and add them together. I have -2 minus 2, so I get -4 square roots of 18. But now as I look at 18, I need to consider, can I simplify that? And I can. -4, and we can do 9 times 2 to get 18. So we do negative 4 square roots of 9, square root of 2. Square root of 9 is 3. So we're going to do negative 4 times 3 is negative 12 square roots of 2. You do need to make sure that your final answers are simplified. All right, let's look at multiplying and dividing radicals. So first you multiply the coefficients. So let's take a look at our example. We're going to do 5 times 7 to get 35. Secondly, I multiply the radicands. So I'm going to do 3 times 2. So we have the square root of 6. And then simplify if we can. If I could simplify the square root of 6, I would. But since I cannot, this is our final answer. All right, let's look at our first example. We're going to multiply the coefficients first. So 7 times 8 is 56. Then I'm going to multiply 5 times 10. So we have 56 square roots of 50. Next, I'm going to look at 50, and I'm going to realize that it is not simplified. I can break that up into 25 times 2. Bring our coefficient of 56 down. And I'm going to do 56 times the square root of 25, square roots of 2. Square root of 25 is 5, so I'm going to do 56 times 5 times square roots of 2. 56 times 5 is 280. So we have 280 square root of 2, and that's our final answer. Let's go ahead and try another one. So I'm going to start on the orange problem by multiplying negative 5 times, there's really a 1 in front of that square root, so negative 5 times 1 is negative 5. Then I'm going to multiply 10 times 15, so I have square root of 150. And again, I look at that and I realize I need to simplify 150. So I have negative 5. I can break up 150 to 25 times 6. So I have negative 5 square root of 25 times square root of 6. Square root of 25 is 5, so I have negative 5 times 5 times square root of 6. Negative 5 times 5 is negative 25 square roots of 6. Finally, let's look at the blue one, our last one here. So we're going to multiply 2 times 2, which is 4. Then I'm going to multiply 20 times 5, which is 100. I look at this and I need to simplify the square root of 100. So I have 4 times 25 times 4. 4 times the square root of 25 times the square root of 4. 4 times 5, square root of 4 is 2. 4 times 5 is 20 times 2 is 40. Now, you could have been all the way back up here and realized, 100 is a perfect square. I can right away make that 4 times 10 to get 40. And that's totally fine. But if you didn't think of that, you could have solved the other way and you would have gotten the same answer. Now, when I have a radical being squared and I see that the coefficient and the radical is in parentheses and both parts are being squared, I'm going to need to square both parts, because essentially what this is 7 square roots of 3 times 7 square roots of 3. So we do 7 times 7 to get 49. 3 times 3 is 9, so 49 square roots of 9, which is 49 times 3. So our answer will be 147. Let's try another one. We have 5 square roots of 2 squared. So we're going to do 5 square root of 2 times 5 square root of 2. We do 5 times 5 to get 25. Square root of 2 times square root of 2 is the square root of 4. And we have 25 times 2, which is 50. Last one, we have 10 square roots of 2 times 10 square roots of 2. 10 times 10 is 100. 2 times 2 is 4, so we have the square root of 4, which is 2. 100 times 2 is 200. All right, now mathematicians have come up with this idea that there cannot be any radicals in the denominator for it to be simplified. Okay, and so we do not want to ever leave that radical in the denominator. So let's say, for example, we have 1 over the square root of 2. We cannot leave that square root of 2 in the denominator. And so we're going to be very clever, and we're going to actually multiply this by 1. Instead of doing it as 1 over 1, we are going to use the idea of whatever is in our denominator, which is square root of 2. And square root of 2 over square root of 2 is the same thing as 1. So this is a legal math move. And we're going to see what happens when I do that. On the top, I'm going to have the square root of 2. On the bottom, I'm going to have square root of 2 times square root of 2, which is square roots of 4. And from here, I can simplify it a little bit further. Square root of 2 on the numerator. Square root of 4 is 2. And look at that. We do not have a radical in the denominator anymore. And for some reason, those mathematicians say this form is A-okay. Even though it's equal to this first form, they say that first form is not okay. We have to leave our answers in that second way. Let's do some practice. Let's look at 4 over square root of 5. We're going to, again, multiply it by 1, but we're going to be very clever about how we do that. We're going to multiply it by the same thing that's in our denominator, so the square root of 5. And then we get 4 square roots of 5. We do square root of 5 times square root of 5 is the square root of 25. We can simplify to 4 square roots of 5 over 5. No radicals in the denominator, so we are happy. Let's look at our orange example. We have 3 square roots of 5 in our numerator and 5 square roots of 3 in the denominator. We don't want that radical in the denominator, so we are going to multiply by 1, but again, we're going to be very clever about it. We're going to use our radical that's in the denominator, so we're going to do square root of 3. Square root of 3 divided by square root of 3. So now I'm going to multiply. I have 3 square roots of, we do 5 times 3 is 15, so 3 square roots of 15 over 5, and then I have 3 times 3, which is 9, so 5 square roots of 9. That's going to give us 3 square roots of 15. In our denominator, we'll have 5 times 3. So we have 3 square roots of 15 over 15. And I look at 3 and 15, and I can simplify those by dividing both by 3. So I have 1 square root of 15. 15 divided by 3 is 5. And to write it in the most simplest form, we're going to get rid of that 1. So we have the square root of 15 over 5. All right, let's look at the top right. Square root of 4 divided by square root of 5. Right away, I can see that the square root of 4 is just 2. Square root of 5 in our denominator. Now I realize I can't leave that square root of 5 in the denominator. So I'm going to multiply by square root of 5 over square root of 5. So in the top, we have 2 square roots of 5 in the denominator. Square root of 5 times square root of 5 is square root of 25. And I can simplify that square root of 25. So I have 2 square roots of 5 in the numerator over 5. And that's our final answer. All right, let's take a look at the square root of 3 over square root of 2. Again, I don't want that radical in the denominator, so I'm going to multiply by 1. And in this case, and in all these cases, we're using the radical that's in the denominator. We're being clever about how we multiply by 1. Square root of 2 over square root of 2. What that's going to do in our numerator, 3 times 2 is 6, so I have the square root of 6 in the numerator. In the denominator, I have square root of 4. I can simplify the square root of 4 to be 2. So we have square root of 6 over 2 as our final answer. Let's look at our last one. Right away, I can see that those 5's divide, and I will have the square root of 8 over the square root of 12. And I could either, 1, choose to simplify these first, or 2, choose to multiply by square root of 12 over square root of 12 and then simplify at the end. Either way is fine. I am going to choose to simplify first. So the square root of 8 can be rewritten as the square root of 4 times 2. The square root of 12 can also be simplified, and that can be written as the square root of 4 times 3. Square root of 4 is 2, so I have 2 square roots of 2 in the numerator. Square root of 4 is 2. I have 2 square roots of 3 in the denominator. I can see right now that my 2's are going to divide. So I have the square root of 2 over the square root of 3. Now I need to multiply by 1 to get rid of that radical in the denominator. And remember, we're going to use that radical in the denominator to create our 1. So we have the square root of 3 over the square root of 3. Square root of 2 times square root of 3 is square root of 6. Square root of 3 times square root of 3 is square root of 9. So we have the square root of 6 over 3. We did a lot of examples in this lesson. If you need to go back and retry some of these, that is just fine. You can pause, you can rewind, you can fast forward. Make sure that you've taken all of the notes on this. We're going to spend quite a bit of time now practicing.